Hi everyone, I am going to be comparing linear and exponential functions today. Now our objective, we are going to observe graphs and tables for exponents and linear functions. Now before that, let's go into linear functions. This is a function that will increase or decrease by the same amount over equal increase of inputs. The constant and amount of change is determined by the slope form. What is the slope-intercept form of a linear function? We all should recall f of x equals mx plus b or y equals mx plus b. M is the slope and b is the y-intercept. Now, exponential function. This is a function that the value will increase or decrease by the same percent of factor over equal increase of inputs. The percent of change is determined by the base b. Now, what is the general form? F of x equals a times b to the x power, and this is where a is a non-zero number, a is the initial value, and b is a positive real number. Now, we know that an exponential growth is when b is greater than 1, and we know an exponential decay is when 0 is less than b and b is greater than 0, and b is less than 1. Now let's complete the table. So we have a linear function on our left-hand side, and then on our right-hand side we have an exponential function. I highlighted it just so you guys could look back into it and you guys could review it if you want to go back into this video. Now, I completed a table for all of you just so we could go quickly into talking about comparing. So all I'm doing is I'm taking my input and I'm plugging it into x. Therefore, 2 times -1 equals -2. 2 times 0 equals 0. 2 times 1 equals 2. 2 times 2 equals 4. And 2 times 3 equals 6. Now, what is happening here? We have a -2 and a 0. How did this occur? This occurred because we're adding by 2. So if we add -2 plus 2, we're getting back to 0. If we add 0 plus 2, then we're going to 2. And if we add 2 to 2 plus 2 again, then we're getting 4, and so forth, until we do the rest. And we could also be adding more points if we needed to. So what's occurring in this table is that f of x increases by 2 each time x increases by 1. Therefore, our input is increased by 1 and our output will be increased by 2. And with the linear function, as it's mentioned in our description, it's the same amount. It's constant and it never changes. Now let's go to an exponential function. This is an exponential function. It has an exponent. That's how we know it's an exponential function. And we're doing the same process. So how do we get back to 1? We're dividing by 2. And then how do we get from 1 to 2? We're multiplying by 2. And then from 2 to 4, we're also multiplying by 2. And how do we get here? We're actually also multiplying by 2 as well. So a difference between exponential and linear function is we're either subtracting or adding, and an exponential we are dividing or multiplying a number. So f of x doubles or is multiplied by 2 each time x increases by 1. This is the difference between the tables. So now let's go into our Desmos and we are going to type in our exponents functions as it has been shown to make a little comparison of our graph. So 2 to the x, we see we have a line right here. And I want to do a different graph of f of x equals 2 to the x power, and we're getting a exponential growth.